Welcome. Now I'm going to show you how you can use this API. So first, let me show you real quick the specification for the return and response, the type of responses you can get. So obviously you can get the 200 response, which is a happy path, an okay response. This is where you get the database without any complaint. You can get 201, which is something you get when you create a new element, for example, a new customer or a new album or a new track. And this is the other type of responses you can get. You can get the 400 response, which is a bad request. And here it is, the kind of message you can get. I think here's an error. I think this is an array, not an enum. So I'll go back to this later. You can get the 401 authorization response. And remember, that is the second filter that you're going to go through to get to this API. First, you're going to get if the server is in maintenance. You're going to get that information. If not, you can get through this unauthorized. And if you don't have an access token, you're going to get your request is going to get rejected. So here I'm returning an additional information about when you don't have permission to access this API. You can get the 404 not found response. This happens, for example, when you try to delete a record that doesn't exist in the database. The 409 response, and this response, you get this response when you are trying to create a record that has an attribute, a unique attribute. For example, the email address is unique for every user, for every customer, for every employee, at least in this API. You can get the 500, and this is used as a generic record, as a generic response. I think this error, I used this error when there's conflict with the database. For example, the database is down, something that most of the time we as developers cannot control. So, but we need to be prepared for that. And something you get in the first place, this is something, the 503 is something you can get if the server is in maintenance state. That means that you cannot go through until the server goes back. So now let me show you how you can use this. So first, let me go through the first path, and this is when you're using an ID to get trying to get a record from this database. So here I can say maybe 200, 152, 125. So this is the endpoint when you try to get an element by ID. This is this is the payload you get back. This is a 200 response, okay. And this is when you try to update a record from the database. Let's try this one to update this one, the 125 record whose ID is 125, the record whose ID is 225. So let's try to update this. So here is. Let me paste this here. And add this here to 125. So I don't need this. And Spanish moss sound portrait. For the name, let's change this to Spanish moss. I don't know what that is, but album ID, this belongs to your album maybe 10. The media type is 10. The genre 2, Billy Cobham, milliseconds, bytes. Let's try to update this. And no media type in the database with this media type. There is a rule that we broke, so I'll get to you this later. So let me continue this with a media type of 1. There it is. This is what we updated. So let's go back to get element by ID. So it is the new record. So now I can go try to delete this record. So this is a delete method. And let's delete this 125 ID. There it is, deleted track ID. So let's get the ID by ID, to get the track by ID, which is this one that we just deleted. And there is the response, not found. The requested track with ID 125 could not be found. So now let's go back and try to search an element. So here, let's try Paradise. And this is what you get. Remember that the specification says that when we are acquiring data that a list of a long list of data. We return that the specification specifies that this is returned in the form of a JSON object with the links attribute, with the links element and the data element, and the links contains the prep and next endpoints that allows you to go through the next page and the previous page from your current request. So remember that the page are optional. So here, this is what we found. Maybe rock. There it is. This is a longer where. I don't need this. I think rock is enough. Where search term is rock. Let's try this again. There it is. And if we can try to go back to the previous page using, let me copy this and open here this and try to send the previous page. We're going to go to, there is nothing, right? Because if we are in the previous page, there is no previous page. So we're going to get an empty, so invalid page, because this is null. And if we try to get to the next page, which is, let me paste this here. I think it's here. This is the next page from our previous search page. And I think I could go through all of the type of how these responses look like. So this is an OK response. This is a bad request. This is an authorized response and a generic response. Unexpected error, try again later, and a service unavailable response example. So remember, for the search, the page is optional. So now we can go try to create a new record. So here, let me copy this. I think we can create a new record. So here we can go to the body. There it is. I think I don't know. Road to success. I don't know, something like that. Road to success, and this is media type, maybe 3 milliseconds. Unit price $4. Album ID. Maybe this belongs to the album whose ID is 4. The genre is 4, and this is Adrian Smith. So let's try creating this new record. So this is let's try this. So this is a bad request. Byte should be less or equal to 30 millions. Let's try this again. So this is the restrictions that are being applied to the when we are trying to create a new record. So I'll show you this in a bit. So let's change this to less or equal to 30 million bytes. So here 30 million. Let's try again. There it is. Let's go back here to database and tracks. Now go to the last element. So this is the record we just created. So we can go now to the get all tracks. So remember that the response is a list of elements of a records paginated. So we can get this data. This will get. Remember that this the page is 20 records. So so there are restrictions for creating and updating elements records in the database. Per specification, if we take a look at our document, you're going to see that there are 4 attributes that are required to create a new track. All of the rest of the attributes are optional, but there are also restrictions when you use them. So here, let me show you how this looks in Postman. So we tried to create a new record. For example, this one. So I tried to create this. Let me close all of these tabs, close other tabs. So you're going to see that the name is required, which is this restriction, the media type ID is also required. The media type, the milliseconds, and the unit price. The milliseconds and the unit price is required. And there is also another restriction for creating a new track. Remember that these are optional, so that there are requirements that when we use them. So in this case, for example, to create a new record, the ID of the album ID must exist already in the database table. If not, the creation is going to be rejected. And you can find this here in the model, where it's set in the trackings model. So here are all these specifications in code. So these are all required. The name, the media type ID, the milliseconds, and the unit price are required. The name has 200 max length limit, and this is should be unique. This name is unique in the table, and it's also an alphanumeric space, which means that we are not using characters that are not alphanumeric or the space character. The album ID needs to be already defined in the database, in the table. It's a natural, not zero. The media type is similar, and the genre ID is exactly the same. And the composer has a max length of 220 characters, and it must adhere to this regular expression. In this case, we are using alphanumeric characters. We require alphanumeric characters, and the space. We can use the space, and we can use the this is the the single quote, and I think that's it. And the milliseconds needs to be 1,200,000, which means about songs about 20 minutes long, and the bytes 30 million bytes, which is about 30 megabytes, and the unit price has a restriction of $4. So let's try that. So here we are breaking the rules of the required attributes. So now we can try the to create. Let's go back to create it. Let's close this and try to update again this here in body. So name bad apples. Here the media type. Remember that the media type needs to be already defined in the database. So here, if I go to media types here, there's only 5 media types. So if I try to add a number 6 here as a media type, it's going to be rejected. The milliseconds, remember that there's a limit of 1,200,000. So 1,100,001. Unit price is $4. So we can add here $4.01. The album ID, let's try maybe 30, and the genre ID, here the max number or the max ID is 25, so let's try 26. Here, and the limit here for bytes is 30 million, so let's try 30 million and 1. Let's try this. So this is a bad request. No media type in the database with this media type ID. No genre in the database with this genre ID. The milliseconds should be less or equal to 1,200,000 milliseconds, and the byte should be less or equal to 30 million. And the unit price should be less than $4. And all of these restrictions in code are defined here. And so now let me show you how how did I make this. So I'm going to start by showing you how a couple of helper classes that I used here. So let me I used the this base64 URL encoding class to help me to encode the string. In this case here I'm using a data string. I need to encode this data that is coming through this as a parameter of this method, and the data in this case look like this. So this is how I define a page. It's just parentheses. This is a JSON object with a key value pair. So in this case the key is the ID, colon, and this could be null or a number. So this is a null when there's no page, when there's no previous page or next page. And the page can be in this case I use the first an element, a record ID as the first element of the next page. But this is what I am coding. He's, for example, 45. This is something like this. This is just what's coming here in the data variable or in the data parameter. Let me remove this. So this is encoded in a base64. With the base64 encoding algorithm, I strip these characters because remember that a URL cannot accept any character. So we have that limits. We cannot use all of the we can't use any character we want. So I need to strip these characters from the string and then trim the equals the equals character from string. This class can also decode the string, so which is the opposite of what I'm doing here. And I think so. This is the get element ID from page. Yeah, in this case, I receive the page, the encoded page, and what I do with that is first I decode that string, because remember that it's encoding in a base64 URL using the base64 URL base64 algorithm for URLs. So here I decoding that into a string that is the JSON string. Then I try to decode the JSON code with that JSON string, and if this object returns null, that means that for a reason this function could not code the string, and throw an error and return an invalid page as a message. Then I get here the ID of the element, and if that element I need to validate this ID. If this ID is not numeric, I'm throwing an error, which is a page an invalid page. Remember that this throws an exception, and I'm going to show you in a bit how I use that in code. And here's how I encode the page. Here I receive an ID. I create an array with this characteristic. This is just a key pair element, so the ID and the ID I'm getting here, I encode that as a JSON string, and finally I encode that JSON string into a base64 URL encoded. This is exactly the opposite of what I'm doing here. So now let's go back to the controller. Don't save your track. So let me start with how to get a page. So here I'm getting the page that comes in the request. Remember that this page is not the page is optional. So if the user do not sense a page, that means that we need to return the first page. And in the case when the user is returning a page, this is the example here. This is the page. That's a page. So remember that it's optional. So this is what we get. In this case, invalid. This is an invalid page. But so if the page is set, which is in this case, well, not in this case, where page the tracks and page equals something. I think I did something wrong here. Let me copy this. I think I can use this here. So where page is this. So this is here where the user is sending a page. So if the page is set, and if the page is not set, it goes here. So in this case, I need to return the first page. So here I query the first page to the database, and what it does is let me go to my model. So here this is the page. This is the MySQL query. So let's go here to the database, and let's here to SQL, and let me copy this code here. So this is let's paste this here and this here, and this is select everything from tracks where track ID is greater or equal to, in this case is ID 1, order by track ID ascending. I think I can copy this. So track ID ascending, limit 21. Let's try this. So this is what we get. The first 20 elements are going to be returned as the page, and the 21st element is going to be the first element of the next page. So in this case, to return a page, I use the first element of that page as a ID as the first element of the next page. Remember that here I am requesting the elements whose ID is greater or equal to this ID, and I'm limiting that to, in this case, 21 records. So here in tracks, I get that page, and if that page returns an empty result set, that means that I need to return an OK response with an empty payload. And if if that is not empty, I get the first page like this. Remember that this is nullable. If we are return the first page, that means that there is no pref page, so I need to return null. So now this is how I get the next page. The first thing I do is get the count of this result array, because if the result set contains 21 elements, that means that there is next page. We have it here, the last element. So if that it goes here, if we have 21 records, that means that there is a next page. So I need to get that. So here I pop the last element of the result set, which would be this, the 27th, this element, this record. I pop that from the result array, and I return. Remember that the array pop removes the last element, which is the 27, the element whose ID is 27, and I use the ID to return the first element of the next page. And with the resulting 20 records in the result set, I return that as the data element of the payload, and the links, and I return that. I return this object in the response and as an OK response. And if we do not get the page, if we do get in fact the page, that means that I get the element ID from page. Remember that the base64 URL helper is helping me to get the ID from the page, which is a base64 URL encoded string. So I get the ID, I get the page starting from that ID. For example, this one. Let me see what page it contains. So let me decode this here, remove this and paste and decode. So this is the 47th element, the element whose ID is 47. So I think if I go back here, so here I'm getting the a page, so that would be the 47th ID. Let me try this, whose ID is 47. So this is what we get. Remember that the last element is the first element of the next page, but this was the 47 was the first element of the next page from the previous request, which is this list. I'm returning this element, this 20 records as a page. So get the page, then I get the prep elements ID. So in this case, the user is requesting this page starting from the element whose ID is 47. That means that I need to get the previous page will start from the 46 element going down. So for that I need to order the query descending. So this is get prep element by ID, and this is the query. So here SQL and remove this and paste this. So get the track ID, select track ID from tracks where track ID is less than something. In this case is 47, ordered by track ID descending, and I only need 20 records. So continue. So this is the closest IDs from in this case the 47th, the element whose ID is 47. So I need to return these elements as a previous page. But remember that the last element of this, I ordered this because the last element of this result set is going to give me the first element of the previous page, which are all of the elements, all of these elements. So here what I do is get these the previous IDs, and if this result array the page is empty, that means I need to return an OK response with an empty payload, and if not, I get if I am in this case, if this is not empty, I define this as a null. But if the previous array, which is the get element by ID, which is this result set, is empty, that means that if that is not empty, I need to redefine the prev page. So in this case, I pop this element from this array and return this element's ID as the previous page. So that would be the 27 element. This array is not being used. I only need this to get the first element of the previous page, and this page contains all of these elements. That is why I query the elements whose track ID is less than that specific ID, and these are the closest elements to this ID. Then here I create the next page. So here to get the next page, the first thing I do is to count the elements coming from this query to get the page. And if the count is less than 21 records, that means that there's no next page, and I define the next page as a null. If the result set is 21 records, that means that 21 records, that means the 21st record is the first element of the next page. So I pop that element from the result set, and that means that I remove that the last record from this result set, and this is the 20 records that I'm returning here, and I defined this ID as the first element of the next page. So here we have the next page, and I add these two arrays, the links array and the data array, or the result set, to my payload, and I return that as an OK response here. So now let's go to the getTrackById function. So here I'm surrounding this within a try block. Remember that because we are executing a database code, that means that eventually we could get an error out of this, because well, the database is something that we as developers most of the time we can't control. So if that ID that I'm getting here in the track ID, remember that this is per specification. So this is this path. So here I'm getting that element from as a last segment of the URL. So if that is not numeric, or that ID is less than or equal to 0, that means that here I'm throwing an exception, and that is the exception is a cut here. So I return a get bad request response with this message, and then if everything's okay, I can find that track by ID. This is a query that goes to the database, and this is just pretty simple. We're getting the track by ID. This is just a simple select a query, and I can go back to the tracks model controller. So if that is empty, that means that we didn't find anything in the database, so we can return a get not found response with this ID. And if there's data, then we return an OK response with the first element of the result array, which is the element that contains the track we are looking for, we are searching. And if we are, this is a generic response when there is something wrong that we are not cutting here. So we need to return. Remember that this could be an error with the database. So this is getTrackById. The search track is pretty similar to the getAllTracks paging response. We are just here adding a search term. So here the first thing I do is validate this, or creating the rules to validate this string. So here the rules are the search term is required. It has a max length of 16 characters and a min length of 4. It accepts only alphanumeric strings with an added space. And this is all of the messaging that I'm using given every one of these errors of these rules. So this is the message for the required. If we break the required rule, this is the message. This is the min length message, the max length message, and the alphanumeric space. This is the message if we break that rule. So here I'm validating this method belongs to the model. I mean, this method belongs to the well, it is it belongs to the controller. So here it has the validation rules. I create an empty error string because this is what I need to return that in, and I get the error from the validator from this from the controller. And if it's set and it is not empty, that means that I can add that error to my errors array, and I send back that array with a bad request response. If everything goes as we expected, the validation was approved, I get the page from the request, get the validated data, the sanitized data, which comes from the validator. We getting here the search term, and this if the page is set, that I get here from the request. I do this, and if not, I do this. So here I don't have a page, so here I need to return a pref array with an empty pref string, pref page. So here I do exactly the same I did with get all records in the page, get all tracks in the database. Of course, paginated. So here is empty. I return an OK response with that object, which is per specification. This needs to be null, empty. And if not, I count the elements. If the elements are less than 21, then I return this null because there is no next page. And if we got data, we do this, and I return this object as a payload in an OK response. And if we got page, the user requested a page, we parse that string and get the ID out of that string. Check if it's not numeric. We throw an exception in the case this is not numeric. We get the element by search term. This element get pref element in search by. Get pref element in search by. Here, the request we are doing here is this select track ID, where track ID is less than from ID. Remember that is the previous page. Where like a name is like a name we are getting here. So the name of the column, return the records where the column name is like the name we're getting here, ordered by track ID descending, limit 20 characters. So these give us the elements that belongs to the previous page. Let's try this in MySQL. So go here and SQL, and let's comment this out. I think I don't need it. So let's try this and comment this too. So this is a select track ID where track ID is less than track ID is less than. For example, let's get this. This is a search, so let's go here and try this. And here I am searching for rock music. Rock. Let's try this. So here I'm getting the first page because we are not. Remember that the page is optional. So here I am not sending a page. So let's try to get the next page. Remember that the first element of this is 17. The first element of the first page, that would be 17. So this and page is equal to this. So the previous page for this is 17, right? Because it's the first element of the previous page. So we decode this. The previous page starts with 17. So here in my database, with track ID is 17. I mean, remember that I need to return here. I need to find the first element of the previous page, which is in this case is 17. So I need to return this. I need to use this here in my query. So with track ID is less than this, where track ID like this is like a name, and this is rock. Order by track ID descending, limit 20. For example, this is something like the track ID column and field list is unknown. So this is the select track ID, where select track ID from tracks. select track ID from tracks where track ID is less than 2221, like rock, ordered by track ID, descending limit 20. Empty. Let's go back here and select track ID. Tracks where track ID is less than 2221, like rock. Select track ID where track ID is less than rock. Ordered by track ID descending limit 20. Fine. There's something wrong. What the hell happened? Remember that I'm looking for the previous page. And what is the previous page of this? Here is less than 2221. Order by descending, select track ID from tracks where track ID is less than 2221. And this is end. And a name like rock. So this is what we get. Remember that this is the first element of the previous page, and the last page of this request would be 2269. So we try to get the previous page. We're gonna get this result set that starts with the ID whose element is 17 up until, or the last element of this page is the element whose ID is 2269, which is this one. And so this search term, then if that is empty, that means I set the previous page like this, which is what happened here. And now I need to create the next page. So result array tracks, get page from search, and a page. Here I'm using the search string and the page to get a list of tracks. So if the result array, I count the elements. If all of that records are less than 21, that means that I don't have a next page, so I return null. If not, I pop that element. Remember that I am not using this array. I only need this because of the first element of this string gives me the last element of this string gives me the first element of the next page, and I return that as the object in my get OK response. This is the messaging if this error is caught here, and this is a generic error, so it's basically the same method than this one, but using a string to search in the database. So here I'm creating a new track. It is also surrounded with a try catch block in case of an error. Remember, we are dealing with database. We are requesting data from the database, and the database is something we cannot control most of the time. So here you get the JSON object coming within the request. If that JSON is not set, I am returning this error, and this happens when the user do not send the payload to create these objects, these new records. So here in the post, the user tried to send an empty payload, and he's requesting to create a new object with the post method. So this is what he gets: a probable culprit and no object. We aren't sending anything to create, so we aren't sending any payload. So this goes here, and if this is empty, which means that the user is sending here in body, and this is an empty payload. This is also a bad request, a 400 bad request, and the message is an empty object. And this is happening here. And if not, if everything goes as planned, we can try to save that JSON. Remember that the tracks model using trying to save this JSON. Remember that tracks model has the skip validation turned as false. So here we are in fact doing validation, and these rules are being applied here to create a new record. So this is saved call with this JSON data. So if that element was in fact inserted, which is here, that means that I get the insert ID and assign it to this variable. So here I insert this, find the track ID that I just inserted, which is I try to find that track by ID, and this ID is the element I just created with this method, with this function. And if there is no error, that means that I return the create response, which is a 201 okay response. I send the new track, that is the first element of this result set, which is 0 index, and I send the location of the new endpoint, which is the track that I just created. If not, if for any reason I can create the new record, that means that I get those errors from the validation object. I get those errors. I create an empty array, and for each error contained in this track model, in this list of errors, I push that message to this array, and I return that array as a probable culprit here in the bad request response. And this happens when we are where is it? I think it's here, and we are trying to create a new record. This is the post method when you are trying to create a record, and we are validating these attributes that are required and these elements that contain another restrictions. So here happens this, and if there's an error here, first I need to check if that error is an invalid track ID. That means that I need to return a bad request with that invalid track ID. Or if that exception is, I'm getting this message from the exception, and this is where it is being defined. So here, out of all the errors I could possibly fall into, I need to. So this is generic error. So now we can go to the update track. So here, remember that here I define a new set of validation. So here I am. I'm getting this ID from the as a last segment of the URL. So I check if that is numeric. If not, I throw an error, an invalid track ID. I get the JSON object from the request. If that object is empty, I'm returning the no object message. If that element is the payload is empty, that means that then I return the empty object message. If not, I try to find the track by ID. I need to know before I can update that element. I need to know if that element exists in the database. So I query the database with this ID, and if that result set is empty, that means that I can return the get not found response with this ID. But if the element is already in the database, that means that we can update it. So first, what I do here is redefine the validation rules for this track. So the name in this case is not required, because remember that this is an update, so this is not required. None of the attributes of this payload is required, but it contains another validation that need to be passed before we can update that element. For example, the name, if present, needs to be less than 200 characters length. This is unique, means that we cannot use this. We cannot insert the same song in the tracks table. And this alphanumeric, we are only allowing alphanumeric characters and the space. And this is the message. If this rule is broken, or is broken, the album ID is natural, not zero, and it is not unique, which means that we need to have this element in the database before we can insert a new track. The same goes to the media type ID, and the gender ID. The composer has a 220 characters length, and it must match this regular expression, which means that we're using alphanumeric characters and the single quote. And the milliseconds has needs to be less than or equal to 200,000 milliseconds, which is about 20 minutes length. And then the bytes, which has 30 million, should be less than or equal to 30 million bytes, which means about 30 megabytes. And the unit price needs to be less than or equal to $4. So here I reset the validation rules to my model. I get the JSON from the request and assign this to the data variable. If I can update that tracks, remember that the validation is being used here in the update method. So if we can update that element, I find that track by ID in the database, and I return that as a response, as an OK response. If not, for whatever reasons, we couldn't update that element, that means that I have access to the tracks array. I create my own array, and for each and every message that is in the errors array, then that belongs to the model. That means that I add that message to the errors array, and I set this to the object probable culprit, the errors, and return that as a bad request. And I send the object back that contains all of the errors coming from this validation. So here I am returning a bad request. If that error is caught here in this try catch block, that means that if that is a track ID, that is exactly what the message that I'm returning. If it is a no object or an empty object, or if there is something we aren't expecting, for example, an error with the database, then I return a generic error. So now we got to the end of this controller. So delete track, this is actually very easy. So here I surround this code with a try catch block in case of an error. And if it's the first I do is validate the record ID I'm trying to delete. Remember that this is coming as a last segment in the URL. If that is not numeric, I return I throw an exception which has been caught here, and that means I return a get bad request with that message. If not, I find the track that element by its ID. This is a direct query to the database. If this result set is an empty set, that means that there's no element with that ID, so I can return a get not found response with this ID. Else, if there is the element here, I try to delete it. Remember that this is the message I'm returning, so delete the track and the element whose ID I just deleted, and I returned as an OK response with that object, with that payload. So now I think we can upload this code to GitLab. So let's do that in the next video. Thank you so much for watching.